want you to box off the word linear. And I want you just to think for a second, if I said something is linear, what does that mean? What do you think it looks like? A line. So linear patterns means anything that if you were to graph it, it would look like a line. That's what linear means. If you were to graph it, it would look like a line. Your learning target today is to determine if a relationship is linear or nonlinear from a table. Actually, that's not really accurate. Your learning target is to calculate rates. You're going to calculate how something changes. So, make a bubble around this big bolded equation. This equation represents any line. Any line in this whole entire world, as long as it's a line, has an equation that looks something like this. Y equals mx plus b. Remember, what is important is a line is made up of x and y values. That's what a line is. It's a collection of points. You plot and plot and plot and plot and plot and plot, and you get lines. Okay? However you want to do it. And you can make an equation out of any line by this. Y equals mx plus b. So, linear moves at a constant rate. That means it's always changing by the same thing. If you recall from 7th grade, we found slope. Slope is a slope of a line. It's a rate of change because it's always constant. And it is a straight line. That means there are no breaks. It is constant, a constant change. That's constant. See, it just keeps same rate. Is that constant?
No.
No. I'm going up a little bit, and then I'm going down, and then steep, and a little bit down. That's not constant. Constant or not constant? Constant, always the same. Constant or not constant? Constant. Always the same. So as long as it's always the same, it's constant. It's nonlinear if it doesn't move at a constant rate, or if it's not a straight line. We found our nonlinear right here. It moved randomly. Or you can talk about, well, a lot of our stuff that we've done in 4.1 is nonlinear. You didn't just have a constant increase or decrease. Most things are random. So like this, that is nonlinear. That's not a constant. Constant means it goes on for infinity and beyond at the same rate. In rate, oh lovely rate. That's what we're going to be dealing with today. Rate is how fast something's changing, okay? The rate of your speed in a car, miles per hour, how much your miles are changing over your time. The rate on how you grow, how much your height changes over how many years have passed or months. Rate of, I don't know, I think that's all I'm going to do. But for linear equations, linear means there's points, which means it's the rate as how x and y changes. We call this m. Rate is m. Mark it down. Rate is m. M is the rate. M is, right here, do you see it? This is rate, which is slope. But we'll get to that in chapter 5. Chapter 5 is way better than chapter 4, just to let you know. So, how you find it is you see how y changes over how x changes. Now it seems confusing, maybe right now, but once you see me in action doing it, it's like, oh, well that's easy enough. So, to find rate of change from a table, you see how does your y change, how does your x change, and you keep it as a fraction. Simplify if needed, never turn it into a mixed number though. Okay, determining linear relationships from tables. Linear means x and y are being added or subtracted by the same thing. Constant rate. Yep, this is fun. Nonlinear. Nonlinear. Now, nonlinear would mean if you are multiplying or dividing by the same thing. So linear looks like this. Nonlinear, if it's changing by multiplying, multiply means really fast. It does. Multiply means really fast. So this is what a graph looks like of by being multiplied. It looks like this. That's not a straight line. It's curved. It's growing exponentially. And some of you did this with that decay that you did in science. Okay? The decay rate or something. Or if there's no pattern. If there's no pattern, it's nonlinear. So, linear, add and subtract the same thing, 2x and y. Nonlinear, multiply or divide. Linear is a line. Nonlinear can be jagged or a exponential growth, which means that it's going way too fast. It's got a curve. You're not going to need to really identify those today. You just need to identify rates from a table. So, it's how, remember, m is equal to how y changes over how x changes. So I ask myself, how is y changing? What did I do to -4 to get to 2? Oh, we're not so confident of this. What did I do to 2 to get to 8? Plus 6. What did I do to 8 to get to 14? Looks constant. What did I do to -4 to get to 2? Okay. What did I do to 2 to get to 5? What did I do to 5 to get to 8? What did I do to 8 to get to 11? So it looks linear. Linear means that I'm adding or subtracting the same thing. Now my rate of change, my m, is equal to how y changed over how x changed, which is 2. That's my rate of change. My rate of change is 2, or my m. M is a rate of change. So all I do is I look at my y's, I look at my x's, and I see how they change. What did I do to 5 to get to 9? What did I do to 9 to get to 13? 13 to 12? Uh-oh, is that constant?
No.
Okay, so right away I could say nonlinear. So you don't have to do anything with that. If it's not constant, it's not linear. There's no rate of change. There's no constant rate of change. Okay. So again, I go to my y. What did I do to 7 to get to 10? 10 to 13? 13 to 16? Okay, now let's check x. What did I do to 3 to get to 4? 4 to 5? 5 to 6? This is linear then. I'm having a constant rate of change, and so my rate of change, or my m, is equal to how y changed over how x changed, which is just 3. And I don't know, maybe some of you want this down here, so it's aligned with that one a little more. Okay, again, I always go to my y side. What did I do to 12 to get to 9? -3. 9 to 6? -3. 6 to 3? That looks constant. Now let me check my x's. They have to be constant on both sides in order for it to have that constant rate of change. -3 to -2? No, plus, because you're getting closer. You're getting closer. -2 to -1? -1 to 0? So that looks constant, so it's linear. So my rate of change, or my m, is equal to negative my change in y over my change in x, which is -3.